Hey everyone, my name is Vedelin, and in this video we're going to talk about Zephyr 7B beta. This is a Mistral 7B fine-tuned version that is more well aligned for chat applications, at least according to the authors. We're going to have a look at the technical report associated with the model. Then we're going to go into a Google Colab notebook and take the model for a spin. If you like this content, please like, share, and subscribe. Let's get started. The technical report for Zephyr is available on the archive. It's called Zephyr Direct Distillation of Language Model Alignment, and it is provided by the H4 Helpful, Honest, Harmless, Heavy team. So these are the guys that are providing us this fine-tuned version of Mistral 7B. So the main aim of this model is to provide as small as possible version of something that is more well aligned to what the user also want. And in this case, they're trying to beat or get over the limitations provided by the Mistral 7B and provide even better model with only 7 billion parameters. So one important thing is that the code and the data, etc., everything is available on the alignment handbook on GitHub from the HuggingFace repository or organization. So the first thing here is that they are describing the strengths and weaknesses for the Zephyr 7B. And you can see that they're comparing with ChatGPT, LLama2, the 70 billion parameter chat model, Quad, and GPT-4. And as you can see, the Zephyr 7B model is performing very well on the humanities tasks, writing, roleplay, but is seriously lacking, at least compared to GPT-4, on reasoning, math, coding, and data extraction. But in some cases, it is providing much better results compared to LLama to 70 billion parameters. So this is very interesting. We are going to test this in a bit. And I would say the main contribution of this model is this technical report is the way that the guys are training this or fine-tuning this model. They're incorporating 3 different tasks. So they're mainly training this model in a supervised fashion. So they are generating multi-turn AI dialogues using GPT-4, I believe, but this dataset is known as UltraChat. So the dataset actually consists of different prompts and outputs, and these dialogues are fine-tuned in a supervised fashion for this model that is again on top of Mistral 7B. Then we get a generation of responses from different models, and then they're using GPT-4 in order to rank the responses. And then they're using this thing called direct preference optimization, which is essentially going over without the need of a reinforcement learning in order to optimize for the preferences that are provided to the model. So they're essentially, from all of the responses, they're getting the best and another random response, and then they are saying that the better response is actually should be a better preference for the final model. So this is essentially the 3-step process of fine-tuning. It is very interesting and very detailed. Again, they have the UltraChat dataset, and then they're using the UltraFeedback dataset as well. So both of those datasets are open source. And this is a bit of explanation on the different types of steps. So as we've talked about, they're using the teacher language model. In this case, they're using GPT-4 and ChatGPT. And then for the distillation, again, they're using AI teacher. So essentially, at the start of building those large language models, for example, for the ChatGPT model, we've been using human feedback at the start, but now we have much stronger AI models such as GPT-4, which can be used to train further these smaller models and improve on their responses. So you can go over the technical report right here. They have very good explanations of each step and how they're actually using the datasets. Also, the UltraChat dataset and the UltraFeedback datasets, again, for the UltraChat GPT 3.5 Turbo, and then for the UltraFeedback, we have 64K prompts from GPT-4, which is great. And then these are the benchmarks that are using the MTB or the MT bench. So this is a multi-turn benchmark. And then the alpaca eval, single turn benchmark, where a model must generate a response to 805 questions. And then they're actually scoring the results using GPT-4. So this is the way that they're evaluating these models. This is pretty common now. And this is the result of the evaluation. And as you can see, the Zephyr model is actually performing better than the Mistral one, at least on the empty bench. We don't have evaluation score for the Mistral on the alpaca eval, but you can see that the models with even 70 billion parameters, at least to this benchmark, some of them are lacking the performance that we're getting here. The LLama2-Chat is actually performing better on the alpaca eval, but it's performing worse on the empty bench. And then you can see that, yeah, the GPT-4 is actually performing much better compared to pretty much everything else except this X-Win model. I'm not familiar with that. Maybe I should try it out. Yeah. So this is pretty much another benchmark. And you can see that the Zephyr model now is compared to the Mistral model. And you can see that the Zephyr is actually providing much better evaluation scores compared to this. And then we can compare this to, for example, with Llama 2. And you can see that the Llama is still performing better. This is the 7 billion parameter model, except for the truthful QA. You can see this right here. But overall, it seems that from the 7 billion parameter models, this one is performing very well. This is the Zephyr model, of course. And one very interesting tidbit that I found right here is the question that the authors are posing: does overfitting harm downstream performance? Since they are training the model for more than one epoch, and they have a very nice chart here, they're actually training the model for 3 epochs. And you can see that the authors are actually saying that, surprisingly, this did not harm downstream performance on MT Bench and Alpaca Evo. So it was pretty much common knowledge that if you are fine-tuning these models for, or training these models for more than one epoch, you're going to strongly overfit, and then this should probably harm your downstream performance. But the authors right here say that they didn't experience this, so this might be very interesting to investigate further. Of course, how much training you can get for a model might be dependent on the hardware and the costs that you have. So it is not always feasible to go over 3 epochs or even more if you're training such a model. The Zephyr 7B model is available on the HuggingFace repository, and it is under HuggingFace H4. And here you can find the model along with the files. And these are pretty much very nicely sharded. You can see that each shard is under 2 gigabytes of HDD space. And you can see that they're providing a safe tensors for this. So we are going to essentially load this model using only a Google Colab that is available for free. And here you can find the same graphic and the same evaluations that they did, along with the graphic that I've shown you from the report. And they are also describing that you can use the apply chat template from the transformers library, which we're going to use in order to get this type of prompt. I'm going to show you this in a minute. And here you can find the training hyperparameters. One important thing here is that they're training on 16 GPUs. And these are the batch size for the total training size. It is 32. You can see the alpha and the betas and the epsilon values for the optimizer. You can also see a warm-up ratio too. And then the number of the epochs. Okay, and yeah, also the warning rate. Yeah, it's really low actually. Yeah, they're fine-tuning this for a bit. And you can see the different loss at each step. So this is really helpful if you want to go over the training history of this model. Something interesting about Zephyr 7B is that the authors from the Llama Index are saying that this model can actually be used with data agents. And if you're familiar with something like LangChain's agents and then something like AutoGen, probably this model is going to be available for these libraries, and we can use this as an agent right there. I have a Google Colab notebook that is using a T4 GPU, so this should be available from the Google Colab free tier. And here I'm adding just a couple of dependencies. I'm using the latest version of Torch, the Transformers library, then the Accelerate and Bits and Bytes libraries. We're going to load this model into 8-bit format. And here I'm just running the HuggingFace H4 Zephyr 7 beta. And you can see that I'm loading this model into 8-bit format, and I'm using the D-type of float 16. I'm going to allow this model to produce at most 1024 new tokens, and then I'm adding this temperature, which is very low, so we can try to get as much as possible reproduction for this model. So this is going to take some time and download all of the safe tensor files that I've shown you from the HuggingFace repository. And then I'm going to create this pipeline. I'm going to use the model, the tokenizer. I want this to return the whole text, and then the generation config, and I want just a single sequence, and I'm going to do this pipeline for text generation. So this is the system prompt that I'm going to use. You're a salesman and beat farmer known as Dwight Schrute. So this is the prompt. You can read it on your own. And I'm going to first try to see whether or not we are getting the correct format for the prompt. And I'm going to use the apply chat template function from the tokenizer that is relatively new, introduced within the, I believe, the last version of the Transformers library. And you can see that I'm adding a row as system, and then I'm adding the system prompt right here, and then a row as user. What are the pros and cons of ChatGPT versus open source large language models? And this is the prompt when I do the apply chat template. You are seeing that the system prompt is actually applied. There is this special end of sequence token right here. And then we have the user. So the system, the user, and then the assistant response. Here also we have the same token. And yeah, let's try the actual prompt right here. And this is the output. You might note that this took a lot of time, 2.5 minutes in order to produce, which is very slow. Yeah, of course, but maybe on a newer GPU, this might be much faster. And let me know if you have some tips on how to optimize the speed of these large language models, since at least on the T4 GPU, they appear to be very slow to run. And here is the system prompt, the user, and then when it comes to choosing between ChatGPT and open source, there are certainly pros and cons to consider. And I would say that this response is very non-Dwight-like. Nothing specific says that the system prompt has been applied in any way. So yeah, I wouldn't consider the system prompt very helpful in this case. Of course, the pros and cons are relatively good. And then I'm going to create this function called predict. I'm going to add a system prompt and messages if there is a system prompt. And I'm going to essentially redo the thing that we did right here. And then I'm going to use again the system prompt. And I'm going to say that I want this model to write an email for a client for a subscription for a paper supply for 1 year. And this is the email. I hope this email finds you well. As valued customer, we at Dunder Mifflin Scranton are delighted to offer exclusive subscription. Thank you for considering for our paper supply needs. Salesman and beet farmer Dunder Mifflin Scranton. Dwight Schrute. And these are the benefits. But again, nothing that Dwight might say. I mean, this email is very professional, etc. But nothing about the Dwight's personality showing up right here, except for this part, I would say. Okay, so the next prompt, I have $10,000 for investment. How one should invest it during times of high inflation and high mortgage rates. Inflation and high mortgage rates can be double-edged sword for investors. I recommend focusing that offer a hedge against inflation, such as treasury securities, real estate investments, inflation-sensitive apartments or storage facilities. Again, I understand what it is saying, but yeah, really nothing that is this Dwight specific from this response. Then I'm going to go without the system prompt at all, and we're going to ask it a simple question, calculate the answer, 3 plus 8 minus 2. And then this is the answer that is giving me. It says that it is 5, which is wrong. But then again, it is giving this explanation. And it says here that the answer is 9. Therefore, the answer is 5. Very strange. And then I'm asking it to think step by step. The final answer is 5. Okay. So the expression is equivalent to 9. So if I asked it to think step by step, it did find the correct answer. But if I didn't, you can see that, yeah, you can, it's strange that it put this here. But yeah, still, it found the correct answer if I asked it to think step by step. And then I'm asking it another math question. So this is 2 plus 4 on power of 2. And you can see that the answer is correct from the first one. Yeah, it found the answer on its own, but on the first, I would say, easier one, it didn't. I had to ask it to think step by step, so this really helped. Then for the coding part, I am adding or trying to create a function that squares the sum of two numbers. And this is essentially the function that is giving him. It is a bit verbose on the code side, but then when you try the function, it appears to be working just fine. And then I'm going to ask it to write another more complex function, write a function in Python that splits a list into 3 equal parts and returns a list with a random element for each sublist. And this is the response that it's giving me. And if you take this response, you see that the random library hasn't been imported. And then this is capital letter I, which is wrong since this is using small i's. And if you run this, you get an error, but I fixed it for it and imported the random library. And then I've changed this to a lowercase I. And then I call the function, and again, it appears to be working just fine. At least on those two functions, it seems that it is performing very well. Next, I'm going to add an abstract from the Llama2 paper, and I'm going to use this model in order to describe me the benefits in a bullet list. So optimized for dialogue use cases, outperforms open source chat models, may be suitable for closed source models, detailed description provided for fine-tuning and safety improvements, pre-training and fine-tuned from 7 to 7 billion parameters. So it did create this very nice summary of the benefits of the Llama2 model from the abstract. So I would say that it did very well here. One very common task where large language models, at least on the open side, and some of the private ones are failing is the data extraction part. And I'm going to essentially give it this table, which is a comparison between different Llama 1 and Llama 2 models from the original repository for Meta when the model was released. And I'm going to ask it for this value, LLama2-7B reading comprehension score, which is 61.3. And I'm going to give it the table within a markdown format. And this is the prompt that is getting it. And then I'm asking to extract the reading comprehension score for LLama2-7B. And then it says that the reading comprehension score is 61.3, which is correct. And then it's providing some more information about the table. I'm not really interested in that. It's a bit of a verbose model, but the answer is correct. And then I'm going to ask it how much better was the increase from Llama1-7B to Llama2-7B. And then for that, it's going to need the reading comprehension score for Llama1-7B, 58.5. And you can see that it is getting the correct value here, the correct value for the Llama2. Then it is providing us with this calculation, which is at 2.8. And then this is going to be the difference. And then it's going to divide that by the original Llama 1 score and then multiply it by 100. And then this is the final response. And this is very well done indeed. This is it for this video. We took a look at the technical report for Zephyr 7B beta. Then we went to the Google Colab notebook and tried out the model on a different tasks. We've seen that the model is failing on some simple tasks, but it is performing very well on some of the more complex ones. And if you do some prompting, maybe you can get the model to reason much better compared to a simple prompting techniques. I would say that the system prompt didn't appear to be doing any significant work in order to change the personality of the responses, but that's all right. Maybe some of the older models or even more fine-tuning will help you get that. I'm going to include a link to the Google Colab notebook within the GitHub repository that I'm compiling. Thanks for watching. Please like, share, and subscribe. Also join the Discord channel that I'm going to link down into the description, and I'll see you in the next one. Bye.